So dear participants, welcome back with our discussions on the coursework of programmable logic controllers. Let us start with a new topic with this lecture, and today we will be talking on various input output devices that can be attached to the PLCs. Now see, the spectrum of input devices that are switches or sensors and the output actuators, that is so large. The complete spectrum is so large that it is not possible for any individual to complete the aspects of every input or output device in the ambit of a single coursework. And moreover, I believe that you have got already the coursework on industrial instrumentation in your first year. So whenever you go through the coursework of industrial instrumentation, and whenever you find any transducer that is having an output which is of electrical type, please remember that can be attached to the PLC. However, you need to be very considerate about the signal level that is generated by the sensor at the output, because unless it is compatible to the standards of the PLC, that is, if the PLC is having a 4 to 20 milliampere input card and your sensor is giving out a signal of 0 to 10 volt in full scale, then they are not compatible. So accordingly you need to decide that which sensor has to be applied. Now this is the most important part. You remember, suppose you are having a certain temperature transducer. That temperature transducer gives a difference of signal, say in the range of 2.4 volt when there is a change in 1 degree centigrade of the signal, suppose, and you are using a PLC which is having an ADC in such a manner that the ADC will be sensing 5 volt at minimum. 5 volt at minimum. That means that unless there is a change in 5 volt at the input side, the PLC will not be able to detect the quantization. So this is the thing. This is the important thing, that now you are able to understand that if we want to read signal from that particular transducer, then this PLC is not going to suit the purpose. I have taken a very I should say a broad example, but you need to take care of all these things. Now you see, whenever we talk of a sensor or a transducer, there are several terminologies that are associated with it. It can be the accuracy of the sensor, the resolution of the sensor, the minimum reading that is possible with the sensor, that is the lowest detection limit, the complete window of operation, that is another important factor that you should consider it while selecting a sensor for a particular application, repeatability of the sensor, response time of the sensor, recovery time of the sensor, I should say lifetime of the sensor. All these things are there. I am not going in detail of all these parameters that define the characteristics of a sensor. Only what I mean to say is that whenever you are trying to measure any field input, whenever you are trying to measure any field input, or you are trying to apply any particular actuator for certain field output requirement, then it is very much required that you are thorough with the characteristics of the sensor as well as the output characteristics of the sensor, especially so that you can be very much sure that whether it can be attached to certain PLC or not. Now once you are very much comfortable with all these things, you know your process parameters perfectly, because whenever you are working as a system integrator or you are working as a solution provider end, you need to know the customer requirements, you need to know the process requirements very perfectly. Unless you are 100% sure about that, don't go ahead. Be 100% sure. Once you are sure about the signal levels that you are getting at the sensor, once you are sure about the sensor that yes, this sensor is going to suffice the purpose, now you see what are the signal levels that is available at the output of the sensor. Now you look at the PLC that you require, or you look at the PLC which is already installed at the site. See whether both the signals, the signal and the CPU, whether they are compatible or not. Once you are sure with all these aspects, then yes, you are free now to connect your sensor and the input terminal of the PLC. When you are very much sure about the current requirement of your actuator, the voltage requirement of your actuator, the type of your actuator, and the proper protection that is required to connect the actuator to the PLC. Once you are very sure about this, connect them to the output. There is no problem. But unless you are sure of all these aspects, do not connect input devices or output actuators to a PLC. Otherwise, you may damage the PLC with no sooner than connecting the stem and supplying the power to your units. Now you see that I will take up a simple example before getting into complete discussion about this particular aspect. Suppose we are in a bottle filling plant. That is, you have bottles. Okay, you have bottles and that has to be filled with some sort of liquid, and this entire process is going to be automatic. The bottles are continuously being carried through a conveyor. The bottle is being filled by some solenoid operated faucet, and definitely in order to increase our headache, the types of the liquids that are being filled are different. And at this point, I ask you to ensure in an automatic manner that the bottles have been filled or not. So if I say you that you are filling the bottle with Coca-Cola, now Coca-Cola is a black colored liquid. Coca-Cola, since it is a black colored liquid, you can simply think of a through beam electrical sensor. Now through beam electrical sensor is a particular type of photoelectric sensors where there is a source and there is a receiver. The source is connected to one side of the conveyor and the receiver is connected to the other side of the conveyor in a manner that the optical path is perfectly aligned. Under such situations, whenever there is no object in between the source and the detector module, then there will be an optical connection in between them. That means that whatever signal the source will generate, that will very easily reach the detector, and the detector will generate a significant signal that can be read by the PLC. So whenever no object is there, the PLC is getting continuous signal, which is a digital signal. Definitely digital signal means it is either 0 volt or 5 volt or 10 volt according to the type of the sensor and the PLC that you are using. Now you see, this type of signal can either be on or be off. That means this is a discrete signal if you want to classify it in the terms of the signals that we have seen already. One is the digital type, other is the discrete type, and the third one is the analog type. Now you see that whenever there is no object, there will be the signal, and whenever there is some object coming and it is actually disrupting the signal, it is breaking the signal, then we can be ensured that yes, the signal has been broken. That means some object is there. Now suppose your bottle is coming. Let us first take the example of the PET bottles that are now used across the entire beverage industry. Now you see, if we just think of a PET bottle through which a laser light can pass very easily, so we are considering a through beam sensor that is generating a laser light at the source that will pass very easily, and you are able to detect that yes, there is a bottle that is empty. Now the moment you put the Coca-Cola inside the bottle, the Coca-Cola is a dark colored liquid that will not allow that laser light to pass through it. Now whenever such filled bottle will be passing, then every time the bottle passes, you get a disruption in the signal. The signal will be broken. So this is a very good example where you can find that your bottle is filled or not, and you are happy with the sensors. Now let us make the situation a bit complex. Let us talk of not Coca-Cola but Sprite or simple water bottle. Now you see that laser is perhaps able to pass through a bottle filled with water or Coca-Cola or this Sprite because it's a transparent liquid. Now what we will do? Now you can see that the earlier sensor, which was perfect in determining whether the bottle is filled up with Coca-Cola, is not going to serve our purpose. At the same time, now let us make our situation a bit more complex with more parameters introducing in our discussion. If you use a glass bottle, now do you think that whatever laser light which was earlier passing through a PET bottle, that much amount of laser light will be able to reach the detector? No, because in a glass bottle or even in a bottle, PET bottle filled up with water or Sprite, whatever the laser light will be impinged onto that will be dispersed to a lot extent. So how much amount of optical energy will be reaching the detector is a matter of concern. Now the system becomes complex. Earlier the sensor that was serving the purpose, right now same sort of application, the same sensor is unable to give you the proper signal whatever it is required. Now you see that I will make a rather more complex situation. Let us think of Tetra Paks. Tetra Paks means the box or carton type packs in which nowadays you can find real juices to be sold, that real company juice. You can find Tetra Pak filled up with milk, Tetra Pak of fruity or the slice. So how this Tetra Pak is completely opaque or non-transparent in nature? How can you feel that whether the liquid has been filled or not? You see, the problem is same whether a bottle or a pack is filled up with certain liquid or not. That is the question. But how many considerations have to be done while choosing a proper sensor to ensure one particular parameter, whether the liquid has been filled or not? What are the parameters? What is the type of bottle? What is the color of the liquid? What is the density of the liquid? Whether the bottle is transparent, whether the bottle is non-transparent, whether the liquid is transparent, whether the liquid is non-transparent, whether the bottle is a paper pack, whether the bottle is a tin pack, whether the bottle is a PET pack, whether the bottle is a glass pack. So all these things have to be considered just to see whether the material is there or not. Normally what we find that analog measurements are very tough. Whenever some analog parameter has to be measured, we feel that it is very tough. Okay, analog measurement is there, but let me tell you, even digital measurements are not very easy. The process requirements are very critical. So every time you see anything, try to find the process behind it and try to ask yourself, if I want to measure this process, which sort of sensor should I use? Unless you do this exercise by your own, you see, no teacher will tell you all these things. Even I will not tell you, you go over there and see. But it is up to you to make this exercise. When you ride a motorbike, you see that your wheel is rotating and You can determine the speed kilometer per hour, or you can determine the RPM of your wheel. Try to find the sensor that is connected to that wheel. Try to know that earlier it was a analog, this pointer type detection unit. Nowadays it is digital. What can be the mechanism behind that? So all these things are there. Unless you keep on asking yourself all these questions, you will not find the answer by yourself. And again I tell you, the day when you start asking yourself the question and start finding the answers by putting your sweat, by putting your tears, let me tell you that there will be no requirement of Kunal Datta or any teacher to teach you, because you personally can become the best teacher of yours. Anyway, let's get back to our technical topic. You can see in this particular figure that there is the input side and there is the output side. You have got a central processing unit, and this input, central processing unit, and the output, they make the entire PLC. You can, as I have already told you, you can connect a plethora of input devices, a wide spectrum of output devices to the PLC, and most importantly, you need to know the process parameters very well, the output of the sensor that you are using to measure that process parameter very well. You need to know the type of input card and output card that is being employed in the PLC by the manufacturer very well in order to connect your sensor or the actuating device to the PLC. So with this much introduction, I start with the basic topic, and I will start with input devices first. You can see the input devices, they can include digital as well as analog devices. Okay, your application can be simple position detection, for which you can use mechanical switches, proximity switches, photoelectric switches. If your application is a bit more complex, like you want to measure position of the object, you want to know its velocity, you want to know the acceleration, which is more required for rotating bodies, then you can use encoders. If you want to measure some analog parameters, you can use temperature sensors, pressure switches, you can use flow meters, you can use level meters. If you want to measure very simple angular displacement with a very low cost solution, you can use simply a potentiometer. You want to measure very minute linear displacement, you can use linear variable differential transformer. You want to measure very feeble amount of force that is being applied, you can very easily use a strain gauge. For again temperature measurement, you can use thermistor, thermotransistor, thermocouple. Or if you want that if the temperature has reached a certain limit, then the furnace should be off, or if it is below that limit, the furnace should be on, you can very simply use a temperature switch, where you need not to be bothered with the temperature what is there in the furnace. You are not looking forward to measure the temperature of the furnace, only you want to have a control over the on and off in a bang bang manner. You can definitely use a temperature switch like that. So there is also a difference. What is a temperature switch and what is a temperature sensor? The temperature switch only senses the temperature and puts something on and something off, just like a bimetallic strip. Okay, I hope you have all studied the bimetallic strip, so I will not get into detail of that. So likewise, there can be so many different spectrum of sensors that you can connect to the input. And therefore, I request that you be very serious about your industrial instrumentation coursework. That will give you idea of many such sensors. Now you see, what is a sensor? The sensor is a term that is used for an input device that provides a usable output in response to a specified physical input. So you see that if there is a physical input which is changing, the change may be analog, the change may be in a discrete manner, the change may be in a digital manner, definitely, which we have already discussed in our earlier lectures. So whenever such changes is there, and our human perception cannot feel the changes, then it is very much required that you employ a sensor. Over there. What the sensor actually do? The sensor translate or interpret that change to a usable output. Usable in the sense that you are able to use that. Now you see, whenever we are trying to measure temperature of a patient with a thermometer, so unless you use a thermometer, you can only touch the body of the patient or the forehead of the patient to see, your body is looking a bit warmer. But how much warm? This can only be measured by knowing the temperature of that particular human body. Now you put that thermometer in proper place of that body contact and you try to measure the temperature of the thermometer. Now you see, if it is a very old one, analog thermometer, there is mercury in that. The mercury will get expanded and it will denote a particular mark onto the thermometer. Now you see what is actually happening. The change in the physical parameter, that means the change in the temperature, that is giving you an usable output. The usable output in the sense that expansion of mercury has been made and calibrated in such a manner that you can read that. That becomes an usable output. Okay. So this is the way a sensor helps you in measuring any physical input. Next comes the terminology transducer. Transducers are generally used for a device that converts a signal from one form to a different physical form. Particularly in the sensor terminology, in the instrumentation terminology, such physical form is electrical. So a transducer will perceptibly give you an electrical signal at the output. However, you may call, even although it is not I should say defined that way, you may also call a motor, which is an actuator, a transducer. How? It is a debatable issue. You can see that as per the definition, basic definition of a transducer, it is a device that converts a signal from one form to a different physical form. Now in a motor, what you are giving actually? You are giving an electrical signal, and at the output you are getting a mechanical movement. So you are converting a signal from one form to a different physical form. So that's a debate whether a motor can be called a transducer or not. Up to you, you think on that. Now you see, sensors which give digital or discrete signal, that is on off. The outputs can be easily connected to the inputs of the PLCs. Now why I am saying this? Because the sensors that are available for industrial purposes or that are available commercially, they are having their outputs very standardized, highly standardized. So the manufacturers know what the PLCs will be requiring, what the PID units will be requiring, what some transmitter units will be requiring, and accordingly they design the sensors. They do not develop some non-standard output sensor which you cannot easily connect to some of the standard controllers of the industry. Therefore, this connection of the on-off type of sensors are normally very easy. However, the sensors which give analog signals, they need further and serious consideration. With this much, I will stop with this lecture and I will continue with further things in my next lecture. Thank you.